Hey kiddos, hope you're having a great day. Today we are going to continue working on the learning targets, the learning target we have been working on. So we will learn how to simplify radicals. Today we're kind of stepping it up a notch from what we did before. So if you haven't done that assignment or taken those notes, you're behind. So make sure that gets done. Today we're going to be dealing with part 2, simplifying radicals. So we're going to be dealing with stuff that isn't square roots, and also square roots that have, or square roots and cubed roots, whatever it may be, that have variables inside of the radical. So for today, we are simplifying radicals, and this is part 2. So simplifying radicals, part 2, and we're going to start out with just some basic nth root examples. So nth root, that implies that your root isn't always going to be 2. Sometimes you're going to take the cubed root of something. So what the cubed root of something is, so let's say we have let's do the cubed root of 64. So that would be denoted with a little 3 right here. And then you're going to have the cubed root of 64 equals x. So if we remember back to our notes we took the other day, we can also rewrite this in the form of x cubed equals 64. So this is what we're trying to figure out. We're trying to figure out what to the third power is going to give us 64. So in our calculators, I'm not sure if we know this or not, but it's a good calculator tip to know. If you go to math and then you scroll down to number 4, that's the cubed root. Number 5, that's x root, so you can type in whatever number, if it's the 4th, 5th, 6th, whatever it may be. So you can go in there, you can hit 3 radical and then type in 64, close your parentheses, and it's going to tell you 4. So this is going to give us 4. If we wanted to check that, 4 times 4 times 4, yep, that's going to give me 64. So that's what the cubed root means if we were to write this down. But if we wanted to do it the long way or the factor tree way, so let's say we had no idea that we could do this and we just were so confused. So we're going to start by breaking down 64. We know it's a perfect square, but off the top of our heads, we don't know about the cube. So we need to do our factor tree, but we know 64 is 8 and 8. And we can break that down into 4 and 2, 4 and 2, 2 and 2, 2 and 2. So for this one, because our index is a 3, we're not looking for pairs, we're looking for groups of 3. So I have 1, 2, 3 2's right here, and then I have 3 2's right here. So that's going to give me 2 times 2, which is going to give me 4. So that is the process for if you don't have a square root. It's still the same idea, still that factor tree. The only thing that's changing is how many are going to be in your circles, or how many groups of the number you're trying to find. So I didn't write that down explicitly, but I said it. So if you're someone that needs to write that down, please make sure you write that down. Okay, so when you have the nth root like this, sometimes it can just be simple with numbers inside, or you might have something that is like this. You might have the cubed root of 81 x to the third. So there's a couple different ways that you can think about doing this. I recommend starting off by treating them kind of separately. So we're not going to worry about this x to the third. We're just going to worry about this 81 right here. So we're going to make our factor tree. We're going to have 9 and 9. We're going to have 3, 3, 3, 3. And again, our index is 3. So we're going to have a group of 3 with 1 left over. So when we do that, what's in the group goes on the outside, and then what's on the inside, what's left out goes on the inside. So we have 3 radical 3, but remember, it's not a radical. Yeah, this is a good example. See, I almost messed that up. It's not radical 3, it's going to be cubed radical 3. So don't forget, whatever your index is, you need to write that back down in your answer down here. And then we have to worry about our x cubed. So there's a couple different ways you can think about it. The first way you're going to want to check is my exponent of my variable divisible by my index? Is 3 divisible by 3? Yes. So 3 divided by 3 is going to give me 1. So essentially what that means is when you take the cubed root of x cubed, you're going to be left with 1x. Or if you don't want to think about it that way, you could also kind of do a quote unquote, I guess you would call it a factor tree, but not really. But x cubed, that's going to be x times x times x. I think we can all agree there. And I'm looking for groups of 3, and I have 3 x's. So that means on the outside of my radical, I'm going to have an x. So it's going to be 3x times the cubed root of 3. So I know that was a lot. So let's do another example. If we have, let's do this one. If we have the cubed root, it won't always be the cubed root, but these examples are 32a to the 5th. Let's start with our 32. That's going to give us 8 and 4, 2 and 4, 2 and 2, 2 and 2. Okay, we are looking for groups of 3. So there's a group of 3, and then whatever is left over goes on the inside multiplied together. So the cubed root of 32 is going to be 2 times the cubed root of 2 times 2, which is going to give me 4. Yes. Okay. Sorry, that looked weird. And then we're going to worry about our a to the 5th. So we're going to check, is 5 divisible by 3 evenly? No. So we can come over here to kind of for a visual aid. And you're going to have 5 A's. So you're going to have A, and A. I'm looking for groups of 3. So I'm going to have 1a on the outside, and then my other 2 are going to be inside the radical. So this is going to be a times a, which is a squared. So then when I combine these two, what's on the outside stays on the outside. And then it's going to be 4a squared. So another way you could think about this is you don't really have to draw out the a's every single time, but you know that that like a cubed times a squared, that's going to give you 5, because when you multiply, you add, and you can take the cubed root of a to the 3rd. So you're essentially, what factor or what number can I pull out that will give me the cubed root? But I think this, since we're just starting out, I think it's pretty handy to just kind of see what all that means. We'll do one more example of that. So we will do, this one. So I have a ton of examples, trying to pick which ones to do. 4th root of 64, x to the 3rd, y to the 6th. So we'll start with our 64. That's going to give me 8 and 8, 4 and 2, 2 and 2, 4 and 2, 2 and 2. Eventually you'll become pros at being a factor tree maker. So again, our index is 4, so I'm looking for groups of 4. So 1, 2, 3, 4 2's right here. And then I'm left over with 2 over here, with 2 2's. So whatever in the circle goes on the outside. So 2. We're going to have the 4th root of 2 times 2, which is 4. And then we're going to move on to our x cubed y 6. So x cubed. Is 3 divisible by 4? No. Can 3 in any way, shape, or form go evenly into 4? No. So if it's less, if your exponent is less than your index, it's just going to stay the same. So we know that our x cubed is going to stay in our radical, because if I was to make my factor tree, that's going to give me x, x, x. I don't have a group of 4. so it's going to stay in our radical. And then y sixth. Is 6 evenly divisible by 4? No. So if I make my factor tree for that, I'm going to have 1, 2, 3, 4, 5. I'm going to have 6 y's. I can take out 4 of them. So I'm going to have y, 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 y. Well, I have one group of 4 is essentially what I mean by that, and I'm left with 2 y's. So my one group of y comes out, so that's going to leave me with 2y, and my other 2 y's, they stay in. So that's going to be y times y is going to give me y squared. So 2y times the 4th root of 4x to the 3rd y squared. And let's see. So that is essentially how that is done. There is another part on Delta Math that's a little bit more advanced. I'm just going to pull it up on the screen and show you. I think it'll be easier to kind of talk you through it. So let's see. Let's minimize this. Ooh, it's not what I thought was there. No. Okay, so this is simplifying algebraic square roots. So essentially, it's the same exact process. They kind of do it a little bit differently on here. So if you're someone that likes to look at the Delta Math examples, which I highly recommend, this is the same valid method. They're doing essentially the same thing. So if you want to put this in your notes, you can. But actually, let me write this problem down and we'll do it my way. X, and then we're going to have 63, x to the 5th, y to the 7th, and that's going to leave us with 3, x3, y3, x, y, z. Okay, let me go back to my document camera. Okay, so this is the problem we are working on right here, and this is what the answer is supposed to give us. So we have something on the outside here. This is kind of the only difference from that third assignment to this one, is you're going to have something on the outside. Don't worry about what's on the outside. Deal with that last. So the first thing we're going to do is we're going to start with our 63. And again, we don't have an index, so that means it's 2. We're going to be looking for pairs on this one. So we're going to have 9 and 7, 3 and 3 for my factor tree. So that's going to give me 3, and then we're going to have, we'll leave a space in case we're taking anything out, radical 7. So x to the 5th. Is 5 evenly divisible by 2? No. But if I have x to the 5th, that means I'm going to have 5 x's being multiplied. So if I'm looking for pairs, so one pair there with one left over. Whatever circled, you're going to multiply those together. So x times x is going to give me x squared. I have 1x left over, x. And the same thing with y to the 7th. So 1, 2, 3, 4, 5, 6, 7. If I have 7, 6 is an even number, so I'm going to have 2 y's, 2 y's, and 2 y's, which is going to give me 3 pairs. So y times y is going to give me y cubed. And then I'm left with 1 y left over. Well, I should make that in the box. So did we get what we were supposed to? Oh, nope. Did I write the answer down wrong? What did I do wrong here? See? Miss Morgan's not on her game. It's really early this morning. So we are left with this, but we cannot forget about this x that's up here. So remember, it's also on the outside out there. So we have to multiply that in last. So x times 3x squared y cubed. When we multiply, we add. That's going to give us 3x to the 3rd, y to the 3rd, square root of 7xy. Okay, let's do one more example straight from Delta Math. Delta Math, show question, new problem. All right, so we're going to have x cubed, the square root of 36, x to the 6th, y to the 6th. All right, so this one's going to be a little bit easier because we can recognize that 36 is a perfect square, x sixth is evenly divisible by 2, and y sixth is evenly divisible by 2. So the first thing we're going to do, the square root, we don't have an index, so we always assume it's a 2. The square root of 36 is going to give us 6, so no need to make a factor tree. 6 is divisible by 2, so if it's divisible by 2, we don't even have to worry about making my tree. So x6, 6 divided by 2 is going to give me x to the third. Same thing here, it's going to give me y to the third. That's all outside of my radical. So if you can divide them, they come outside the radical. When you take the square root of 36, it also comes outside the radical. That one's pretty self-explanatory. And then I just have to bring down what's on my outside. So this is going to give me 6x to the 6th, y to the 6th. So that one was a lot easier compared to this one that we did over here, but it really all just depends on the numbers you're given as well as your index. There's a lot of different factors. So some of these will be hard, some of these will be easy, but we'll hop on over to Delta Math and we will see, yep, see 6x6, y, oh, sorry, I messed that up. Man, I'm not on my A game today. Let me go back to my ladybug. Yeah, so obviously when you're multiplying x's and x's add, your y is going to stay the same. Don't know why I put a 6 there. I didn't mean to. So yeah, that's what we're doing today and possibly tomorrow. I'm making these videos prior to the hybrid schedule, so we'll have to see how it all plays out. But these are super duper important. This is what we're dealing with the whole unit is stuff like radicals and, breaking stuff down. So make sure you're taking good notes. Bring any questions you have to class whenever I see you. And good luck on your practice. Hope you all have a great day. And I'll see you when I see you.